Test, 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 test. I lowered the frame rate to 10 frames per second. Because it's not like, you know, we're recording a video game or something. You just need to see the code and hear the audio. It doesn't really matter if it's 10 frames per second. So hopefully that'll help with some of these dropped frames. So this is streaming. Okay, let's go ahead and get started. So let's go to where do I put it? Resources, and let's open up REPL. Now I realize for a lot of you that have had me before, I'm reusing a lot of these same examples from COP2030, but again, it's going to be like this period of a few weeks where you're going to learn some basics and fundamentals, and then we'll start to get into more cool, interesting things about the language. So if you had me for COP2030, just bear with me for a few more weeks. If not, I guess it's good practice because you're getting some more basic programming examples if you had somebody else. So. But either way, I always like to make sure everyone's got a good foundation because I've tried to move ahead too fast before, and it's just like a giant disaster. So, okay, let's start off with, do I need to do any language review? Does everyone still feel comfortable with the basics like print? So this is the print function. You pass it a string. We talked about different variable types. Like this is going to be an integer. So it's going to say it's an int. And then unlike other languages like C and C++ and Java, we don't have to declare our variables ahead of time. What happens is that basically whatever this, so in this case 5 is an integer, x is going to be an integer. So whatever we assign it first, that's what it becomes. It's a little bit more complicated than that, but sometimes I have to simplify the explanation. Maybe as we get on through the course, it'll make a little bit more sense. If you're curious at all about what I'm talking about, there's a really interesting set of videos and online material that in Python, variables are actually just labels for objects or primitives that exist in memory. So 5 exists regardless. It's just now that we're pointing x to 5, but anyway. But you can see here, so if we made it like 5.2, that's going to be a float, which if you had me, floats are very similar to doubles. I'm not going to get into the details of the differences. And then we have our third data type that we're working with is a string. Perfect, so str. Now if I wanted to do something like ask the user for their name, bless you. So this input function right here, all this does is does exactly that. It gets input from the keyboard, and whatever string we pass here, it passes the user. So the string in this function, so we have our function called input. It says, okay, what is your name? And then the keyboard waits. You type in your name. And then this thing here was called an f string. And then any code within the curly braces, that's Python code. So in this case, I've got our name variable, and that's why it prints hello Chris instead of hello. If we had forgotten that f, notice the difference, okay? Okay, so let's do our first actual code example. That was just a quick review of terms and everything and get everyone's mind back into Python. Let's just do a quick miles to kilometers converter. Don't forget that this little hash symbol right here, this is our comment. So from here to the end of the line is it's just going to ignore it essentially. And our two basic uses of comments are going to be when we want to leave notes for ourselves, and then the other usage is going to be when we want to what's called commenting out code. So sometimes I'll write a piece of code like this and then decide, okay, I want it to be there, but I just want it to temporarily be disabled. If we put a comment in front of it, since everything is ignored, so you'll see that kind of often, okay? So we're going to do a program that they give us miles, so we take in as input miles, and then we're going to convert it to kilometers. So the first thing that we're going to do is we're going to ask the user, we're going to say, okay, enter miles, so however many miles they want to convert. So what I'm going to do is I'm going to introduce a bug. If you see it, great. Don't say anything. One of the things I'll often do is I don't like to write perfect code in the class every time, because that's not how you write code in the real world, is that you make mistakes and stuff happens. And a lot of times by making mistakes, that's where you actually learn. So if I were to write perfect code every time, I could just put PowerPoints up here. It's kind of more of like an interactive process where I make a common mistake, and then I show you why that's a mistake and why we need to fix that. Okay. So let's do this. We're going to say, okay, they entered in the number of miles. Let's do the conversion, miles times this number. Okay, so don't run the code yet. But this is the basic logic. We're gonna do these kind of patterns over and over again, programming patterns that you'll see all the time. Like in this case, it's get input from a user, do some sort of calculation, and then give the answer back to a user. In this case, we want to do miles to kilometers, so we ask them for the number of miles, store that over here, do the actual conversion, store it here, and then print out to the user the final result. So don't say anything, but stare at the code for a second and don't shout out the answer. Stare at the code for about 10 or 15 seconds and say, okay, why isn't this going to work, you know, the way you might intuitively think? So just stare at it, and then we'll run it and see if we can't see what happened. Okay, so let's go ahead and run it. Oh, yeah, well, that too. Sorry. So the F string, let's run it again. I made two mistakes, one intended, one non-intended. So we do want this as an F string. And so if we set number of miles is 2, can't multiply sequence by a non-int type of float. So we're going to end up in a weird situation. So okay, let's do a little bit of debugging here. So don't change your code, because I'm going to change a bunch of things and it gets confusing. So what I'm going to do is I'm going to say, okay, that's weird. It's saying can't multiply by a float. Well, let me see the type of miles. It's saying that if I want to multiply them, I have to multiply two numbers. And essentially what it's saying is that I'm trying to multiply a non-number by a number. And then, okay, so unlike other languages, like maybe a C++, is that this input function, everything comes in as a string. Now this actually can be useful, because if anybody's ever taken C++, in practice you end up wanting to take in things as strings a lot of times, because then you can do cool things like input validation and other things like that, like checking to see if they, entered in anyway. But so in Python, this took this in as a string. So what do we have to do to that? What do we have to do to that to make it a float? Because we want to multiply a float by a float. Yeah, exactly. You have to convert it or cast it, or I don't think it's technically a cast. Yeah, I think it's literally a function that, but we can say we'll just use the word convert. If say for example in conversation you use the word cast, I think most people would know what you're talking about. But again, yeah, like you said, I don't think it's technically a cast. It's a function that actually returns a new value. Yeah, exactly. What's that? Yeah, let's actually do it both ways. So it's good you pointed that out. So the first way is that we want to So what we could do is we can introduce a new, do something like this, miles float. That way we know it's the floating version. But I've seen a lot of students do this in the past, is that you don't necessarily need a new variable for every single thing every time. Okay? So in this case, so we're not introducing a million different variables. What I'm going to do is, because I know I don't really care about the string version, what I'm going to do is I'm going to say that miles equals, and then I'm going to convert it to a float. So this is the function that it basically takes in a string and it gives you back the numeric version, the float version of miles. Because right now it's a string. Remember, a string is like one of these things where it's like an actual string of characters. We can't actually do math on strings. We can, but we often get unexpected results. Like if we did s times 3, we would get SSS, you know, things like that. Okay, so this, let's try this now. Oh, and one more thing, this always throws a lot of people off, is that, so normally the code runs top to bottom, left to right, but don't forget that in most programming languages, that when you have an equal sign for assignment, the stuff on the right-hand side gets evaluated first. So the way this line number 4 of code actually runs is that it runs this function on miles, it gets back a float, then assigns it to miles. Because if you read this left to right, this would be a weird thing. It would say, you would end up with this, like, and this actually confused me in the early days when I was trying to learn how to program. I was like, wouldn't this not run because you're saying that this is equal to this, and if it runs left to right, then it's going to have some, but it actually evaluates kind of non-intuitively for most people, is that it actually evaluates everything on the right-hand side first, gets one final answer, it evaluates to one value, and then it stores it over here. And then now let's go ahead and run that program again. Now the alternative, what I'm going to do is so what we could have done instead is, like you were mentioning, we could simplify this. And this is, you can take, so think about like math. If you had like f of x and g of x and all that stuff, you kind of evaluate it from the inside out. So if I had, we've already seen this with type. If I've got this function right here called input, I can actually wrap this whole thing with float. And what it'll do is it'll run the inside function first. It'll get a value, and then it'll pass it into float. It basically evaluates this, gets a value, and then float actually, does that make sense? Just like in math, if I wrote something like f of x, g of x, like that, and if you did like, you know, something like that, it's basically the idea that it's gonna evaluate this inside function, get a result, and then it's gonna evaluate that function. Yeah.
What was the shortcut you used to move the cursor to the end of the line?
Oh, like that?
Yeah.
These guys? Home and end. I use these all the time because it drives me crazy having to use the mouse if I don't have to. You see where those are? They're above the arrow keys on the keyboard?
Yeah, I got it.
Okay. Okay, so that's another way, and let's just run the code to confirm 2 miles. Perfect, so it still works. So we'll have both. So I'm going to comment out this version. For clarity, for anybody who's initially learning the language, we'll stick to this, but in the real world, you might see actually something closer to this. Okay. So what I want you to do is let's take 5 or so minutes, and I want you to open up a new REPL. And what I want you to do is the other direction, so kilometers to miles. So the user's going to give you how many kilometers, and let's just look that up. So it's going to be 1 kilometer to miles. So just take a few minutes just to get some practice. No dropped frames this week. Perfect. Okay. Okay, I'm hearing the typing slowing, so let's go over this. So again, that basic pattern, we're going to convert kilometers to miles, so we know we're going to need to store the kilometers somewhere. Actually, sometimes I actually write code out of order. And this is a very common thing, is that we don't write our code one character at a time, beginning to end. It's not uncommon that, like, mentally I'll go through the process. It's like, okay, it's kilometers to miles, so I know I'm going to have to ask the user for kilometers. I've asked that user for the number of kilometers. Well, what I have to do next, I have to actually store that somewhere in a variable so I can use it. Okay, so that line's done, good. Then I know I'm going to need to do the conversion, but the conversion needs to be a float, and I can just do that. And then finally, I know I'm going to need to print the final result, so I can make that an F string and say that, hold on, going to kilometers to miles. Yeah, and then we actually need to do the conversion. So you have to go, miles is equal to the number of kilometers times 0.621. And then we can go ahead and print miles is miles. So everyone good with that? Now don't forget, like we talked about, that Python is white space dependent. So if I start doing things like this code, it's already telling us, this code isn't going to run. Okay. The reason they did this is, the idea is that if you force, so there's what we call code conventions. So you can write really, really messy, sloppy, like C and JavaScript and C++ and Java code, and it'll generally compile as long as the code is correct. But if you've got spaces everywhere and stuff broken up into multiple lines and it's just generally messy code, it doesn't care, because it looks, it runs from the beginning of the line all the way to the semicolon. It doesn't really care in between about, what's called white space. a lot of people will kind of get into some bad habits with that, and there's often very difficult code to read. It's not as much of an issue because actually modern text editors and IDEs are super, super powerful, and they'll actually take really, really messy C code and they'll format it for you. Like, it's amazing how good these are. I took code the other day that it was just a mess. It was like 10 lines of code. Part of it was copied and pasted. I had modified some stuff, and it was just a mess. And then I did the auto cleanup just to kind of get it into a good spot, and it was basically perfect after the auto cleanup. But either way, but in Python, it's this matters. So this line of code is not the same thing as this. Even though, all I've done is hit the space bar a few times, it's white space dependent. And the idea is that messy code shouldn't be able to compile. Now, whether you would agree with that, there's this giant fight in the programming community, whether that's a good idea or not. It's kind of a moot point because that's the path Python chose. It's a very popular language, so this is where we're at. Okay. So any questions on that? So let's do another example. Let's get this general practice with these conversions. Let's open up a new REPL here. Let's do area of a rectangle. So now this one's a little bit different because if I'm going to calculate the area of a rectangle, what two things do I have to ask the user? So first of all, what's the equation for calculating the area of a, so not the area of a square, area of a rectangle? Length times width. So what two things am I going to have to ask the user for to actually be able to calculate the area? Don't be shy. It's probably the right answer. Length and width, right? So let's, before we were only asking for one variable, now we're asking for two. So let's go through that process. Again, we would say, okay, that the length is equal to input. Now, arrays, I always do something larger, like calculating like a class average or like taking in 10 numbers. So we do enter length. And then we need to cast it as a float. And now we have to ask for the width. And it's followed that basic pattern, is that we've asked the user for some data, we've stored it somewhere, but now the only difference is it's kind of a trivial next step, but now we're doing it twice. This is just kind of a general concept in pattern. To be honest, a lot of programming is pattern recognition. There will be instances where you have to work in a system that you don't completely understand, but a lot of times is that to understand the code, you can sort of see, or deal with pattern recognition. So that's a very, very useful skill, because I've seen people in the past really struggle with this idea. They get it once, and then I'm like, okay, how would you do that twice? Should be fairly obvious, but you get the idea. Okay. So now what we're going to do is we're going to say area is equal to length times width. Pretty straightforward example. We've got a 3x4. Oops, what did I forget? F for the F strings. Just out of curiosity, how many people in here have taken any sort of database class, like either Access or the proper SQL class? The most people? Okay. Because what I'm thinking of doing is a lot of times what we do here is introduce classes independently. So this class, all you do is learn the Python language. That's not how the real world works, is that a lot of times if I'm writing a Python program, it's going to interact with the database. And so once we get a little bit more advanced in the course, I'm thinking about introducing some of those things, but I just wanted to see how many people. And the basic idea is I'm not going to try to teach you SQL or anything. What I'll do is I'll show you how to execute SQL statements in Python, and then you take all that SQL knowledge you'd learned from another class. That way, because I realize there's probably going to be a handful of people who've never done SQL. I don't want to confuse them. It's just going to be more like, here's how you execute SQL. If you know how to write in SQL, there you go. You can do that as maybe your project or something. If you don't, keep that in the back of your head for when you do eventually take a SQL class, okay? Any question about this? This one was pretty obvious. Okay, let's just do a few more of these just to get some practice. I know they're boring, but they're quick, and they just get you used to seeing Python code. This is going to be the last one of this style, I guess. Then we'll move back over to if statements. So let's do a tax calculator. So the idea is going to be that, like, so in St. Lucie County, 7% sales tax. So the user gives me the price of an item, say $100. And what I want to do is I want to tell them in dollars the sales tax. So for a $100 purchase, there's going to be $7 in sales tax. What we don't want to necessarily, well, maybe we will. Let's start with that though, okay? So we know we're going to ask the user for the purchase price of their item. So we'll say price. Maybe you could say purchase price, but in the real world, I might say purchase price to be clear, but these fonts are so large that, and these programs are so small that I'm just going to say price. So we'll say input, oops, enter the price, and then we're going to get the price from the user, but again, it's going to give it to us as a string, so we're going to say float price. So now to calculate the sales tax, it's going to be 0.07. By the way, this isn't a great idea to just throw numbers around here like this. These are called magic numbers. We'll get to that later, but I'm sure some of you are probably cringing every time you see me do this. We'll get to that later. So it's going to be 0.07 times the price, and so now we know the actual sales tax. So we can go ahead and give that to the user. So on a $100 item, that should be $7. Ah, this is good. This did this. I'm really glad this did this. So start with this. Let's make sure this is this much works. Okay, so everyone's good with this so far. Did I give you the whole spiel about why you shouldn't use floats and doubles for money? This is the reason. Is because internally what happens is that, remember, computers work in base 2. They work in ones and zeros. What's our normal numbering system? It's base what? Base 10, right? We count from 0 to 9, and then we go 10 through, and so on. And so that's a base 10 system. But computers are really, really good and fast at working with base 2. Because remember, transistors, they're binary, ones and zeros. That's what computers like, is ones and zeros. So what they did is they said, okay, well, decimal numbers, we're gonna represent them in base 2, because we can do really, really fast math on it. Remember the early days of computers? A lot of times in those early days, they were concerned with doing like mostly physics simulations. On a physics simulation, being off by this amount isn't that big of a deal, because oftentimes it's small enough that it's not, you care about the speed that you get a lot more than being off by this little tiny amount. And that's what computers were mostly used for a long time. It wasn't until probably maybe the 70s that we really got into using computers for accounting and billing systems and so on. Now, to properly represent a number, a lot of times numbers are not easily represented base 2. Just like, you know how there's often times where I can do like 10 divided by 3, and it's going to be 3.3 repeating. I can't quite represent that number as a decimal. It's the same idea. Does that make sense to everybody? So what we're saying here is that it couldn't quite represent this base 10 number the way we wanted it. It had to convert from base 2 to base 10, just like we convert 10 divided by 3 into 3.3 and a bunch of 3's, but that's not quite the complete accurate representation. This is why we don't use it for money, is because they chose speed over accuracy. Now for money, what's the most important thing? Speed or accuracy? Accuracy. So what you have to do is you have to use these special libraries that all they are geared to do is represent numbers as base 10. Now they're slightly slower. For money, it turns out it's actually not that big of a deal because money calculations you're not doing. Think about a video game. How many calculations is that doing per second? Physics simulations. Think about FP&L billing. They probably send out a few million billing calculations per month, versus a video game might do those few million calculations in a couple of seconds. So that little loss of speed when you're dealing with money is totally worth it. Versus if you're doing physics simulations, I just didn't want anybody to think that the computer was broken or there's something magical going on here. That's the basic idea. Is that so for the most part, using these data types like floats and doubles, for the most part it's okay. But as soon as you're dealing with money, it's not okay, because accountants are very particular, and for us, being off by a cent might not be that big of a deal, but I have seen systems that at the end of the day, they're off by a cent, and oftentimes they'll have to justify to their auditors, and they'll have to actually make a special note why they're off by a cent. And they don't like to hear that the reason that the total is off is because the software, because that sort of makes everyone question the rest of the software. It kind of lowers the confidence. But anyway, it's good that happened. Now, it doesn't always happen for all values. Let's say, for example, a while ago the sales tax was 6%. Notice that? Yeah.
I just had this thought. You need to round. Numbers for pennies and cents and stuff like that.
Correct, yeah.
How does that play into?
So what they do, and this is good you brought that up, these libraries aren't necessarily geared just toward money. They're typically what are called decimal libraries. And what they do is that they can have as much precision as you want. So that's not uncommon for anybody who does, even though if I were to go to the gas station right now and buy gas, it's not going to be, $10. They're not going to charge me 10.80579112. That's not actually that uncommon in certain industries, is because if the example you gave last week was if you're ordering, there's actually electronic parts that cost less than a penny. And obviously you can't buy one of these parts by themselves, you buy them in bulk. Now if you've got a system that can only charge a penny, the problem is, do you see where the disconnect would be? If something is a tenth of a penny, well, I want to order 10 of them, it's going to cost a penny. If my system can't store a tenth of a penny, then I run into issues. So you're exactly correct. There are actually issues where you might not charge the final customer a fraction of a cent, but internally you might have to deal with calculations that are less than a penny, and that's actually not that uncommon. Those libraries can handle that generally. Okay, so enough of that. Let's move on to if statements. Everyone's good with all these basic calculations? We did a lot of them. Just multiplying some numbers, yeah. Oh, for this class, we're gonna be okay with that, because unfortunately it gets kind of complicated, and we could probably spend a whole class doing that. But there's libraries out there, like you just type in Python. And there's an actual separate decimal module that you would have to use. And notice that it gets a little bit, from decimal import, and that's why I don't want to really, and you set the precision. So you can see that's why I don't really want to get into this right now. It's probably more complicated than we want to get into this early in the class. Okay, so if statements. So let's do this. Let's grab one of our old calculations. I don't know, miles to kilometers. If you already closed the tab, just retype it. So I'm not modifying that old example. All I did was copy and paste. If you need to retype it, that's fine. But we're just going to reuse this. So one of the issues, obviously, that we run into is that if I enter in -3 miles, for most people, maybe like in a physics class, this might have some context, but most people, if you're doing miles to kilometers and you enter in negative, the idea of negative distance, for most people, and obviously in a physics class, that's a different context, but I enter in -3 and it gives me, mathematically, it did the correct thing, right? It did a negative times a positive, which is going to be a negative, but probably not great to have software that does this. We kind of want to do a little bit of input validation. The idea of input validation is that we want to kind of check the values before we do any calculations. It's generally better to this is a general principle in software, is that you generally want to have errors as soon as possible, because when you have errors later in the program, it often has a cascading effect, and it's much more difficult to debug. In production software, oftentimes those errors can take out physical things. Like, so for example, if I'm writing phone software and say, for example, somebody enters in a bad phone number, you don't want it getting all the way into the system, trying to route a bad phone number and then taking out a bunch of phone switches or something. You want to capture it as soon as possible. Okay. So let's go ahead and everyone still remembers if statements from COP2030. Basic idea is, if some condition is true, it's going to execute some code. So it's going to say if, actually, we want to put it up here. So they're going to give us the number of miles. And then we want to say, okay, if the number of miles that they gave us is greater than 0, only then do the conversion. Now, we briefly touched on this last time. Remember, I talked about this idea that we don't have curly braces like you wouldn't see, those sorts of things. And we don't put parentheses around it. That when they created the language, they created it for readability. And so what we do is we don't wrap this in parentheses. We use the colon, so not the semicolon. This is just a regular old colon. And then we have to indent. So hit the tab key. There's this big joke in programming. Has anybody heard the big debate about tabs versus spaces? And I usually just let the editor. A lot of editors these days, actually, if you hit tab, they expand it into spaces. So I hit tab, and this actually expanded into 2 spaces automatically. There's usually preferences. Something like this, like a website, I doubt they have very many. I don't know. Maybe they might. I don't know. Yeah, indent type. So I'm just going to leave the defaults for this class. But anything under here that's indented is going to run. So it's basically going to say, is the number of miles the user entered greater than 0? If it is, it's going to run these 2 lines of code. If not, it'll jump down to line 7, just like, it'll basically skip over this code. So let's go ahead and test that. If I enter in -2 miles, nothing happened. Now, if you remember, we have something that goes along with the if statement that is the else. So we're saying in all other cases, so we can say else, and let's just give a very generic error message that says miles must positive. And then notice that this is not indented. So the way it works is that the stuff inside of this code block right here is indented, and then here it's unindented. And then as soon as we want to get out of these conditional statements and just go back to normal code processing, we unindent. Okay, so no matter what happened up here, and actually maybe this is a better thing to type, this will always print. And the reason that this will always print is because if this condition is true, it's going to execute this code. Otherwise, in all other cases, it's going to run this code. Say, for example, we wanted to have multiple lines. We could do this, like, please try again. But as soon as the code is no longer indented, it goes back to normal code processing. So this will print no matter what, whether or not the user entered in a positive number of miles. Okay. Now we have all the standard comparison operators. We have greater than, less than, greater than or equal to. So this would be greater than or equal to. Okay. Less than or equal to. And then we have our two equal signs, which stands for equality. Now, a lot of people get equality and assignment confused. We'll talk about equality in the next example. Is everyone good with this so far? Do I need to leave this up for another 30 seconds or so? Or is everyone done typing? And does anybody have any issues with the logic or the code or anything? I'm pretty confident. Okay. Just out of curiosity, from a student's perspective, because I've programmed in so many languages over the years, it all kind of blurs and runs into. Do you find this code to be more readable than C++ code? Okay. There's been a big push in the educational system to, instead of use languages like C++ as the first language, to use Python as the first language. But the education system moves slow. I'm kind of on the fence about it. I don't know. There are certain topics I can't teach in Python that I can teach in C++, like pointers. So I'm kind of on the fence. But oh, really? That's great. You know what? They always make this argument that the language doesn't matter, and that's the concepts. But it kind of does. It's like if somebody's teaching me how to like dig a hole, and then, you know, there's a shovel over there, but they're like, we're not going to let you use a shovel. Go ahead and use this, like the lid of a container. You know, it's like, okay, I could use a weird tool. I guess I'm learning how to dig, but why don't you just let me use the tool that professionals actually use? And so.
One positive I can say about Pascal is that it sort of taught me the intro, the basics of Go.
Really?
Well, because you declare your variables before you use them in Pascal.
Mm-hmm.
I'm pretty sure that's exactly what you do with Go as well.
Yeah, but yeah, a lot of languages are like that. But I don't had enough experience with Pascal to really make a comment one way or the other. But at least you know Pascal now, so it's not totally bad. But okay, so let's open up another one of these. Let's talk about the equality operator. So don't get these confused. Equality and assignment are two different things. So let's say, for example, I wanted to print kind of a menu-based system. So what I could do here is, let's say we're doing miles to kilometers. We want to be able to go either direction. We either want to go miles to kilometers or kilometers to miles, but we want to make it menu-based so that the user can choose. Okay, so this program, it prints a very basic menu, and then they enter in their choice. Now we can say if choice is equal to, so let me ask you, without running this code, is this code going to work the way we might think it's going to work? It's always good to look at your code without running it and kind of get the gears turning and then get the answer, because I could just tell you the answer, but you're not going to learn anything in the process. So who do you think, doesn't really matter what's here. There's actually a special, it's called pass. There's a special keyword you can put. So who thinks this will work? Show of hands. Who thinks it won't work? So won't work. Does anybody want to justify your answer? So the answer is it won't work. So you're correct. But why do you think? Exactly. So choice is what? What's the data type of choice? So I'm trying to compare a string and a number, and that's not really a great idea. So we have two options. What we can either do is convert this to an integer. In my opinion, that's probably not really necessary. The reason you might want something as an integer is if you're going to do math on it. In this case, it's just, we're not going to do math on it. We're just checking for comparisons. So in this case, I think it would probably be acceptable just to say 1 as a string. Now, the obviously only problem is that for some people, reading this code can be a little bit confusing, because it's like, is it the number ones or is it the string one? Is it But personally, I probably would have written the code like this. Okay, to me, changing it to an int is probably a little bit excessive. Okay, and then let's go ahead and be lazy. So if the choice is equal to 1, so back on our original tab. So if choice is equal to 1, they want to go miles to kilometers, okay? You don't need this version. This version is more complex. It's going to make the logic a lot more complex. Let's just stick with the simple version. So if choice is equal to 1, they want to go miles to kilometers. Let's go ahead and test that. So if they enter in 1, so 3 miles, perfect. And you can, normally I'm sort of against copying and pasting, but for most people this is your second semester, so to save a little bit of time, I'm okay with some copying and pasting. Now again, I'm going to introduce probably not something great, so if you see the problem with it, keep quiet for now and we'll talk about it. Okay, and then I'm going to say, okay, well I have if, and then we just talked about else. Else I want to go kilometers to miles. And it'll seem like it works, because if I enter in 2, it says enter in kilometers, I enter in 1 kilometer. But what's the problem with that? Does anybody see the problem? What if I enter in 3? It's gonna think that anything else is kilometers to miles, which isn't, that's not the case. It's gonna always assume. So here we're saying if choice is equal to 1, do miles to kilometers. In all other cases, do kilometers to miles. But we know that's not true. We only if they press the number 2 do we want to do this. So in other languages, you might write the full words else if. However, in Python, and I think even Perl does this, we actually use the word elif. And now elif is not a catch-all. We actually have to specify something to evaluate. So we're going to say else if choice is equal to 2. And give this a little bit of space to make this more readable. And so we're getting there. So now if we enter in a random number, we get that. But what might final thing what I might want to put in here just to kind of let the user know that they put in a bad. What's that? Yeah, so like an else and have it say like, yeah, invalid choice. Please try again. Is it okay if I shrink the fonts a little bit? I just want to be able to get a little bit more code on the screen. Is this size still good for everyone? Okay. So everyone's good with this example? Okay, and then let me just show you one last thing. It's not going to be a large example. I just want you to understand the concept. Is that everyone remembers how to and, right? So if condition A is true and condition B is true. So let's say, for example, I'm going to introduce something new here. So we have, we talked about integers. Integers were positive and negative whole numbers. We talked about floats, which are essentially decimal numbers. So like we already saw, it's a little bit more complicated than that. We introduced strings, which are just strings of characters. Now this is what's known as a Boolean. So what I can do, just to show you that, oops, gotta spell it correct. You can see here, it's a class, it's a bool. And let's actually do this. It's somewhat common just to write this, so is registered. Like if I want to know if a student is registered for something. And this is just going to be kind of a silly made-up example because I don't want it to get too long. I want it to be the last thing for the day. And then let's do this. Let's also have another variable called points. Let's say, like, you know how you go to Walgreens or something and they give you points. So you've got 500, whatever, 500 IRSC points, whatever. By the way, so this is a T with a true with a capital T, and what's nice about the syntax highlighting is it'll often give you a guide. So if I tried to do it lowercase t, notice that it did a squiggly line, but it turned blue. So you always use that syntax highlighting as a guide. And so I could do something like this. Let's do, sorry, points plural. So I wrote points singular. Let's do points plural. So if points is greater than 100, we'll just print OK. And this works, obviously, right, because 500 is greater than 100. This is old stuff. This shouldn't be crazy to anybody. But now there are times where you want to check for two conditions at the same time. Maybe, for example, they had to have registered for some prize and also had more than 100 points. Again, this is just a silly example because I want to keep it short. In other languages, we might use the double ampersands. In Python, we actually use the full word and. So we could say if points is greater than 100 and is registered is equal to true. Now, some of you might know the shortcut that you actually, this is sort of redundant information, but for now, let's just go ahead and keep it. And now the only time line 5 is going to execute is if both conditions are true. If points is greater than 100 and is registered as true. In all three other cases, we make these things called truth tables. Has anybody ever seen those before? So in this case, there's going to be 4 possibilities. There's going to be true, true, false, false, true, false, false, true. So there's four permutations, and the only one of those 4 that's actually going to execute this code is if both things are true. So if points is greater than 100 and they're registered. Let's say, for example, they weren't registered. Or the points was below 100. Or they were registered, but the points were below 100. It's not until both conditions are true that this code right here is going to execute, okay? And I'll keep it at that. We're basically out of time. Any questions on anything? So I'll post this code, and then I'll upload it, and then I'll get the lectures in order. But don't forget, next class is just going to be dedicated to helping you with assignment number 2. Now, if you want a little bit of practice, I would suggest this. So this example right here is the area of a rectangle. Now, you can do 2 modifications to this. One modification is that you can check to see if if what they entered is actually a positive number, right? Because it kind of doesn't make sense to have a negative area. The other thing is that for anybody who's ever shipped anything, one of the things that they often calculate is the volume of the box. So what's the volume? We have the length and the width. What third thing do you have to add? The height. So you'd have to add the length, width, and height. Now this isn't going to be graded. What I'm going to do is I'm going to say, okay, if you have the time, I would highly suggest this kind of as a practice problem for yourself, kind of as a ungraded take-home homework. And then the next time we meet for a regular lecture, we'll go over the answer. Okay, so it's not going to be graded. It's just kind of one of those things, hey, work on it a little bit, see if you can find the answer. So the idea, again, the 2 things I want you to do is make it so that instead of finding the area of a rectangle, that you're finding the volume of a box, and then make it so that they can't actually enter in negative numbers. So think about the simplest way to write that, because there's a complex way to write that, and sometimes if you just kind of think it through, you can actually kind of come up with simpler is generally better. As long as it fully solves the problem, you generally prefer simple, because a lot of times people can write code that solve the problem, but the code's so complex that it's hard to follow. The best code is code that both solves the problem and is simple, which is kind of like the ultimate, that's true in life, is that like a lot of times something will seem simple, but it took people a really long time to come up with that simple solution. So, okay. If there's no questions, I'll see those of you on Wednesday who need help with the assignment. Everybody else will see you on Monday. Absolutely, I will not accept late work if you don't show up on Wednesday. Okay, that's the whole thing, is that I'm giving you this time to work on the assignment and do it in class and help you if you're struggling. But if you don't show up and you don't turn it in, you just have a 0 for that assignment, okay? All right, enjoy the classes for the rest of your week, and then I'll see those of you on Wednesday and everyone else on Monday. No dropped frames today. Perfect. Okay.